Alright guys, today we begin our unit on rational algebraic expressions. Okay, one of the things that you should know right off the bat is that a rational algebraic expression refers to basically fractions with variables. Okay, that word rational expressions are ones that are fractions, okay, because rational numbers can be written as a fraction of whole numbers, so rational algebraic expressions are just expressions that are fractions and probably have some variables in it. So the first thing we need to figure out is this basic idea of simplifying. We already know how to simplify basic fractions, okay? Most of us know that 6 over 8 is equal to 3/4, right? But do we know why we're able to do that? Well, there's kind of a couple ways that you could look at it. One way that you could look at it is we could divide our numerator and denominator both by 2, which would give us the 3 and the 4. Another way to look at it, if you want to look at it through the process of canceling, is that 6 can be written as 2 times 3, and the 8 can be written as 2 times 4. It's not prime factorization. And we could then just say, oh, look, our 2's, 2 divided by 2 is 1. That cancels out to 3/4. The key is we are allowed to cancel in situations where we have all multiplication in both our numerator and our denominator. Now, that doesn't mean we can't have an addition symbol or a subtraction symbol in there, but we need to be able to break it down into an expression that is all multiplication, and I'm going to show you what I mean by that. Okay, so let's look at this next one. This next one you should be able to do on your own, okay, because this is definitely review from last unit. Okay, we should know how to do this already. But what I'm going to do is I'm going to rewrite it in such a way that it makes the canceling a little more apparent, the canceling process a little more apparent rather than subtracting exponents. So I know that the GCF of 18 and 30 is 6, so I'm going to rewrite each of those with a 6 in there. And I'm going to change x to the 7th into x cubed times x to the 4th. Now, again, ladies and gentlemen, you don't have to do it this way. I'm just trying to make something apparent to you right now through this example, okay? Because I know you know how to do this one already, okay? 6's cancel, x cubed's cancel. The reason I'm allowed to cancel is, again, look real carefully, 6 times 3 times x cubed. Look at all those multiplication symbols. Primary operation is multiplication. Okay, so I'm allowed to do that canceling. All right, and what I'm left with is 3 over 5x to the 4th. Or 3/5 x to the negative 4th, you could write too. And again, you obviously don't have to do those that way. You know how to do that already, but I was trying to make something obvious, which will hopefully help you in the next one. In the next one, we've got addition and subtraction symbols. So you got to be thinking, well, am I allowed to do any canceling here? Yes, you are. Okay? The operation between the parentheses is still multiplication. So in the end, I can break it down into this parentheses times this parentheses. Same thing in the denominator. The key is, because it's the entire parentheses that are being multiplied, I'm only allowed to cancel if an entire set of parentheses on top matches with an entire set of parentheses on bottom. So here, x plus 2 and x plus 2 match perfectly. So I am allowed to cancel those. And I'm left with x plus 3 on top and x minus 2 on the bottom. We don't need the parentheses anymore because we're not multiplying by anything. Okay, that's the basic idea of canceling and kind of when we're allowed to and when we're not allowed to. There are some tricky things that might come up here. For example, some people wonder, well, if I've got x plus 2 and something on top and x minus 2 and something on bottom, am I allowed to cancel? It's an easy check to see if you can cancel. Plug in a random number for x. They should match if you're allowed to cancel, and they don't. So you can't cancel those. However, if you do end up with something like 2 minus x over x minus 2, you can't exactly cancel those right away, but what you could do is you could factor out a negative 1 from the top and change that to negative 2 plus x. Negative 2 plus x is the same thing as x minus 2. Then you could cancel them and you would just have an extra, that's a negative 1 left over on top. But those are exceptionally tricky examples. I think you got the basic idea now. So now where does factoring come into play? Well, factoring comes into play here. Okay? What you have to do in each of these before you do any canceling at all is you need to factor them completely. Okay, and this is why we worked on factoring right before we started this unit. Okay, so here's what I want you to do. I want you to try to see what you can do to simplify these problems. You need to factor both the numerator and denominator completely, and then see if there's anything that you can cancel. Try these two on your own, pause, and then come back. All right, so my numerator factors into x minus 3 times x plus 2. My denominator, that's difference of squares. And the only things that cancel are the x plus 2's. That's what we're left with, x minus 3 over x minus 2. In our denominator, both of these have a GCF of 3, which, yes, I'm going to be able to cancel out. Okay, so I get 3 times x squared plus 9x plus 20. And then I get x squared plus 4x minus 5 down here. Okay. And now I want to continue factoring. The top factors into x plus 4 times x plus 5. The bottom factors into x plus 5 times x minus 1. So again, I'm in a situation where I have to cancel the whole parentheses, and I can cancel the 3's too. So I'm going to cancel my 3's, I'm going to cancel my x plus 5's, and I'm left with x plus 4 over x minus 1. Okay, that's really it for that canceling process, ladies and gentlemen. It's really not that big a deal, not too bad. Again, the biggest thing is you can't cancel anything until you've rewritten the expression as, with the primary operation being multiplication. And if you're multiplying stuff in parentheses, the whole parentheses has to match for you to be able to cancel. All right, that's all for this one.